you are getting any problem, or you can practice. Okay, otherwise some confusion is coming, and if your concept is not clear, then in future when you are going some particular next advanced unit or an advanced chapter, that time you are getting some particular problem. So your concept must be clear. So again, I am repeating many times. So if you any doubt, then please ask. Okay, don't hesitate. Okay, if it is
yes,
no
sir,
doubt,
I have one doubt.
Please tell me.
Sir, whenever we set the parity bit, we always assume it to be an even parity. Why don't we assume it to be an odd parity, sir?
See what happened when we are parity bit when directly when we are using the parity bit, actually what happened, parity bit only for detecting the errors. Okay,
yes, sir.
So when parity bits only detecting the errors, that means so parity bit also generally parity bit we are using detecting the errors. Okay, yes, but sir. When we are detecting, without detecting, we cannot correct the errors. Okay, so I have already told you. So before correcting the errors, detection is required. Detection technique is required. Okay. So what happened when we are designing the parity bit? That time what happened? Some particular concept we are using based on the even parity and odd parity. You know, parity bit have two types of parity bit: even parity and odd parity. And I have already spent 2 hours class. That means what? When we are constructing, when we are grouping, or suppose parity bit, suppose if I am the earlier example P1 1357, P2 1367, something like that. So that particular group we are constructing from the even and odd part. It is not like that we are constructing only based on the even parity. Are you getting my point? So what happened? It is not like that by default even parity and odd parity. You can use odd parity also. It is no problem. But you have to know what is the concept of how we can put the parity bit if it is even parity, and you know also how we can put the value of even parity based on odd parity. Okay, you can use even parity as well also odd parity, but you know the concept. Which particular what is the value of parity bit when we are considering the even parity, and what is the value of parity bit when we are considering the odd parity. Okay, but generally what happened by default, because by default it is not like that. Naturally people are even paired because many cases we are using, so even is a normal general process. So many people by default it is taking even paired. It is not like that. We are always considering the even paired. Yes. Algorithm you can use also paired. Or any doubt? Any some other student, any doubt?
It's clear, sir. Clear.
Okay, then I will start my next class, today class. So today, after that, now we are coming to the we are entering to the now it is digital electronics. We are going one by one. So last class we are discussing we are discussing a few class we are discussing about the numbering systems and some particular weighted code or non-weighted code. What is the concept? Why we are using? What is the manipulation of that particular weighted coded or unweighted coded? Okay, suppose arithmetic operation, how we are doing. Now what happened? See, now what happened? You know already. In particular, when we are considering one particular device or one particular system, what happened? Some inbuilt circuits are there. Okay, and that particular system, there are different type of components are there. Okay, and that particular components we are built by some particular circuit, or it is called a IC. IC means what? Integrated circuit. Okay, now what happened? When we are talking about the numbering system and all those things, that time what happened? How we can provide some particular input. Now what happened? What is input actually? Input means what? When we are considering one particular device, that time what happened? We are providing some particular type of signals. Okay, and signal is nothing but some type of inputs we are using. Now what happens when we are talking about the inputs, in digital electronics, we are considering only binary sequence, 0 and 1. Okay. But what happens, the long sequence, when we are considering the long binary sequence, that time what happens for human, it is very difficult to readable. That time what happens, different type of concept we are using, different type of conversion technique we are using such that human can easily understand. But after all, what happens, that particular signal convert to the system such that system can automatically understand. Or system already, this computer only understand 0 and 1. So when we are discussing about the logic gate and all those things, after that what happen? Just a minute, someone is want to join in actually. The slide is visible?
Yes, sir.
Okay. So today we are discussing how that particular numbering system, before we are using, how we are designing the circuit and all those things, some particular, how we are doing the operation based on that particular numbering system. Okay. So operation, when we are talking about the operation is nothing but some type of special type of gates we are using in digital electronics. Okay. Today class, that means what we are discussing some basic type gates or some standard type of gates. Okay. And after that, we are discussing some different type of, suppose Boolean algebra and all those things. So what happens, see here, logic gates. So logic gates are the fundamental building blocks of digital system. So what happens in particular system, digital system, there are many type of components are there, many type of ICs are there. Okay. So IC actually, it is constructed by this type of gates. Okay. And if we are talking about some higher level, that time what happens, gate is nothing but some type of operation. Okay. So what happens, the name of logic gate is derived from the ability of such a device to make a decision. Okay. So okay. So when we are considering the name of logic gate, this particular logic gate is derived from the ability to such a device to make a decision. Decision means what? It is very important. Okay. So what happened? That is our main motive actually why we are considering the digital system. Okay. So that means what, in digital system there are two type of voltage are there. One is zero, we can consider low and on, low and high, or you can consider on and off. And if you are going to convert to the binary, that time what happens, zero means off and one means high. Okay. Or you can consider active or deactive. Deactive means zero and active means one. But it is not fixed. Sometimes what happens, we can reverse reverse concept also we are using. Okay. But generally what happens, one means what, it is active and zero means deactive. So what happens when we are applying that based on that particular input signal, that time what happens, our decision must be easy. Okay. And that particular decision we are considering based on some particular operation, and that particular operation is in digital electronics, that particular operation is called a logic gates. Okay. Some particular logics we are using, and that particular logic we are applying in gates. Okay. It produces one output level when some combination of input level. Okay. So what happens, based on some particular input level, we are generating some particular output level. Okay. So what happens, suppose we are using two input signal and applying some particular logic gates or operation, we are producing some particular output. And so it is called a output level. And this particular output level totally based on this particular input levels. Are you getting my point? So whatever that means, whatever the inputs you are providing based on some particular computation is required, and that particular computation is performed by some particular logic gates. Okay. And based on that particular gates, we are getting some particular output level. Okay. And maybe some particular cases, what happen, there are different type of input levels are there. Okay. Based on that particular input level, we are getting the defined type of output level. Okay. So it is not like that the digital circuit always produce only one output level. It is maybe more than one output level. That is the main. Okay. So generally what happen, the logic gates we are constructing with the basic, this particular AND gate, OR gate, this particular three gates are called a basic type of gates. And this is some particular standard gate, NAND gate, NOR gate, and this is also called as some particular universal type of gate, NAND gate and NOR gate. Okay, so I'll discuss details of why it is called a NAND gate and NOR gate. It is a universal gate because it is possible to derive or complete any particular function. Okay, that particular function may it is called a Boolean function. Okay, so Boolean function is nothing but some combination of Boolean expression. Okay, and why Boolean function is required, because what when that particular function derived that what type of circuits is behave. Okay, that all the manipulations is derived by that particular function, and when we are deriving that particular function, some Boolean expression is required. It is called also sometimes it is called a Boolean algebra, sometimes it is called a switching algebra and all those things. Okay, so what happen when we are applying some particular NAND gate or NOR gate, that means what any particular Boolean function is handled by this particular, it is possible to construct any particular Boolean function. Okay, so what happen NAND gate and NOR gate we are calling as a universal gate. Universal gate means what, it is possible to derive any or construct any particular function based on that particular circuit, logic circuit. Okay, and because why not an and or is called a basic type, because what happen if you are using only this particular three gates, then you can design any particular circuit. Okay, and this is also universal gate also we are designing any particular circuit, but basic type means what, this particular NAND gate NOR gate is basically coming from this particular basic type of gates. Okay, some part here it is XOR, or sorry, here it is some mistake is there. You can consider this one you can consider XNOR. So some other particular gates are there, XOR gate, XNOR gate. Okay, so when we are considering this particular logic gates, so what happened, integrated circuit actually designed or constructed by the logic gates. So what happened in the time to time, there are different type of integrated circuit are constructed, or integrated circuits are formed. So when we are talking about the when we are talking about the small scale integration, and short form is SSI, that time what happened, it is less than 12 gates per chips. Okay, and that means it is less than 12 gates is required. And when we are talking about some advanced medium scale integration, that time what happened, it is less than, or it is less than, that means it is greater than 100 gates per chips. Okay, it is greater than 12 gates per chips. Okay, and when we are talking about the large scale integration, and short form is called LSI, that time what happened, 1000 gates per chips. Okay, so here we are not using that means we are considering that when we are considering the LSI, that means 1000 gates are required one particular chip. That means we can accommodate 100 gates per chip. Okay, so very large scale these days, this one is called a VLSI. You heard this particular word or name. So it is what happened, more than 10,000. That means 10 to the power gates, 10 to the power 4 gates per chips we can accommodate. Okay, and also VLSI today's days it is because we can accommodate many particular ICs, one particular components. Okay, so it is some particular advanced concept is actually this particular accommodation of gates per chips, it is already improved one by one. It is generation to generation. So these days what happened, it is called a greater than 10 to the power 8 gates per chips. Okay, so this is for, so this one is required if someone is asking you, so it's just you remember. Okay, so it is development is time to time, that is it is the improvement, how we can include many gates one particular circuit or one particular components. Okay, so this one, so digitally logic gates typically operate on binary logics. This particular logic gates actually what type of inputs we are providing and what type of outputs are coming, it is based on the binary logic. Okay, and remember one thing, in binary logic it is easy to design electronic circuit with two distinct states. I have already discussed, one is called a 0 and one is called a 1. Okay, only two voltage levels are there or signal levels are there. That is called a, one is called a 0 and one is called a 1. So there are two distinct states. But when we are talking about the analog system, what happen? Some particular continuous events are, that means some particular fractional numbers also coming. It is 0, if 0 to 5 volts, they are in between 0 and 5, there are different type of values are occurred. So there is not a distinct states we are getting. But when we are talking about the logic circuit, that time what happened? There are two distinct states are there. Input and output, next point, third point, this one. Input and output of the logic gates can occur only two levels. Okay, these two levels are termed as a, I have already discussed, high, low, sometimes it is called true, false, on, off, or simply 1 and 0. So there are just three basic type of gates. These particular three gates are called a basic type of gates. Remember, and, or, and not. And sometimes not gate, it is also is called a inverter. Inverter is nothing but a not gate. And see, this is the symbol of not gate. This is the symbol of not gate. Okay, so this way we can denote it the not gate. Okay, see, this is the symbolic representation of not gate. So this one is the input, and for this is a dash. A dash is nothing but a complement. So that means if we are providing input, a value is 0, that means that time what happen? Output is 1, and a value is 1, then output is 0. Okay, so this is a very simple gate. This is called a NOT gate, and sometimes it is also called a inverter. Okay, next one, it is AND gate. AND gate, see, this is the logical symbol, okay, of AND gate. And AND gate, see here both the inputs are 1 1, that time what happen? Always output is 1. And logical expression of AND gate is this way, this one, F equal to A dot B. Okay, and if both the inputs are 1 1, that time what happen? Output is only active, otherwise what happen? Output is deactive. And what is the OR gate? This is the symbol of OR gate. And see here, if only in input sequence, if only 1 is present, that time what happen? Output is produced always 1, otherwise what happen? It is 0. So here, see here, only here also 0 is occurred, here also 1 is occurred, here is also 1 is occurred, here is also 1 is occurred. So all the three outputs are 1. But if both the inputs are 0 0, that time what happen? Output is 0. And this is the logical expression we are denoting. That means what? When we are talking about the OR gate, that time what happen? This is the symbol, we can represent this way also. Okay, we can represent this way also. Okay, and when we are talking about the AND gate, we can represent this way, dot, and we can represent this way also. Okay, next one is called a NAND gate. NAND gate is, this is the logical symbol of NAND gate. Okay, and what is the, that means see here when the input both are 1, that time what happen? It is 0. That is the special property of NAND gates. If both inputs are 1 1, that time what happen? Output is always 0, otherwise all the outputs are 1. Okay, and the logical expression of NAND gate is this way. We can define, this is also, you can write this way also, F equal to, you can write this way also, F A also, you can, this way also you can write. Okay, so this is the logical expression. And NOR gate, see here, this is the logical symbol of NOR gate, and this is the just reverse of this one. And when both the inputs are 0 0, that time what happen? Output is always 1, otherwise the output, all the outputs are 0. And this way we can, the logical expression is A plus B complement. Okay, and NAND gate logical expression is A dot B whole complement. This is the exclusive OR gate. So exclusive OR gate, this is the logical representation of exclusive OR gate. Okay, and see here, when when this is the very important, when both the inputs are 0, that time what happen? Output is 0. Also, when both the inputs are 1, then output also 0. Okay, otherwise what happen? Output is 1. Okay, so remember, in XOR gate, this is the truth table means what? Behavior of this particular logic gates. And what type of behavior actually? That particular behavior is represented by the truth table, and this one is called a truth table. Okay, and this one is called a logical symbol. and this one is called a expression. Okay, so what is the behavior of this particular gate? When both the inputs are 0, then also it is 0. When both the inputs are 1, then also it is 0, and otherwise it is 1 1. Okay, and also different type of meanings you can form in this particular truth table. You can say that means see here, if suppose you can say that if odd numbers are 1 in input sequence, then also output is 1. So different terminology we can use to justify the what is the output of this particular XOR gate. Okay, so number of ones are even, then it is what happen. If number of odds, then what is the output? Okay, so you can just you can carefully check this type of truth tables in truth table of every gate. Okay, and next one is called a exclusive NOR gate. It is called a XNOR gate. So XNOR gate means what? See here, if even number of ones are occurred, or and also even number of zeros are occurred, that time what happen? Outputs are 1. Okay, and this one, and now what happen? This now from this particular slide, we are not considering this one is a modulo 2. Now this one is the XOR symbol. This one is also called a XOR symbol. Okay, earlier what happened? We are not discussing this particular part, so we are named as a modulo 2. But from this particular slide from this particular slide onwards, we are considering this particular symbol. We are considering as a XOR symbol. Okay, and NOR gate means what? This is the representation of NOR gate. You can using this one or you can using dash also. It is no problem. But when we are derive this particular expression, we are getting this one. Okay, so this one is the logical symbol. We can use some particular this type of symbol. We are using this one, and we are using this particular symbol. We are using. Okay. So what happens when we are talking about the behavior of this particular gate? If both the inputs are 0 and both the inputs are 1, that time what happens? Output is always 1. Okay, and this way we can represent this way also. This way or this thing is same. Okay. Now what happens? See here. Based on this particular gates are very simple. Okay. So if we are now what happens? Just I'm giving here this particular expression. A XOR B whole complement. If you are deriving that time what happens? A dot B plus A bar plus dot B bar. How we can prove? We can prove based on the truth table. So this one is the truth table. Okay. So what happened? This is the expression. Okay. Okay. Before that, just one thing you always remember, when we are writing some particular Boolean expression. Okay. Suppose we are considering this particular Boolean expression. Are you hear me now? Are you hear me?
Yes, sir.
Yes, sir.
Yes, sir.
You are so silent. So okay, no problem. So when we are writing some particular expression, this is the suppose this is the what? This one is also called a Boolean expression, and some particular books it is also called a switching algebra. Boolean algebra and switching algebra are same. Don't confuse. Some particular books it is called a switch. Why it is switching? Because it is going only two states, 0 to 1 or 1 to 0. Okay, so it is called a switching algebra. Okay, or sometimes generally what happen? Boolean algebra is very common term. But remember one thing, when we are writing some particular expression, that means this is the Boolean expression. Suppose we are considering this one is the Boolean expression. Remember, we are using some particular keyword to express this particular expression. This particular A, if I am talking about the single A, sometimes this one is called sometimes it is called a Boolean variable, or sometimes it is called a switching variable. Both are same. Okay, and sometimes it is called a literals. But sometimes it is called a literals. Okay, and this particular whatever the operation we are using, this is called a operator. Okay, and this is the assign symbol. Assign symbol is same. And what happen when we are considering some particular A dash B? This particular combination of two variables, when we are combining two or more than two variables, that time what happen? This one is called a term. 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 m. It is called also called a term. Okay, apart from this particular expression, we are using some particular constant value. Okay, so always remember when we are writing the Boolean expression, that time what happens? Some particular literals are there, some particular operation symbols are there, and terms are there, and apart from that, some particular constant values are there. Suppose what happens? What is the constant value? Suppose if we are writing a, if we are writing a 1 plus b, 1, 1. So this particular one is called a constant value. So when we are talking about the constant value, we cannot write apart from 1 and 0. You cannot write 5, 6, 7 like that, because we are using only binary values. So either 1 or 0. Okay. So you remember this one, when we are deriving some particular expression, these particular terms are there. Now what happened? How we can prove this particular expression? A XOR B equal to A bar B plus A B bar. Okay. So there are many methods are there based on the Boolean expression method, based on the truth table method. But sometimes what happen, your expression is very lengthy. That time what happen, the truth table method is not applicable, because you can your truth table may be large. Okay, so what happen, based on that some particular expression we are using, that particular part I will come later. Okay, for the time being, just how you can prove this one, that A XOR B equal to A bar B plus A B bar. Just you consider what is the XOR. XOR means what? You know the XOR gate. Okay, what is the truth table of XOR gate? This is the truth table of XOR gate. This is nothing but a truth table of XOR gate. And you know when the both the inputs are 0, 0 and both the inputs are 1, 1, or odd number of ones are over, that time what happen, output is always 1. Okay, when both the inputs are 0, 0, both the inputs are 1, 1, that time what happen, output is always 0. So this is the output of A XOR B. This is the output of what? A XOR B. Now what happened? This is the right hand side expression, A bar B plus A B bar. We can write how many variables we are using. We are using only 2 variables. That means what? 2 to the power 2 is 2 variables we are using. 2 to the power 2 equal to 4. So 4 binary sequence. So 4 binary sequence is required. Okay. So this one is 0, 1, 2, and 3. 4 sequence are required. So here I am writing 0, 0. This is also called a binary encoding. Okay, 0, 0, 0, 1, 1, 0, and 1, 1. You cannot write 0, 0, 0, 1. After that, you cannot write 1, 1. You can come in sequence manner. Okay, and in this decimal digit, this one is 0, this one is 1, this one is 2, and this one is 3. Okay, 1, 1 means what? 1, 1 means 3. After that, what happened? A here in right hand side, see here, A complement is required. So here I am writing here A complement. And what is the complement of A? Complement A is 1, 1, 0, 0. And also B complement is required. B complement is here. B is 0, 1, 0, 0, 1, 0, 1. And B complement is 1, 0, 1, 0. So we are writing. And after that, what happens? See, this particular term we are writing directly here. Okay. So after that, when we are using the AND gate. A B bar means what? Here AND gate operations are there. A B bar. A, this one is A, and this one is B bar. So 0, 1 is 0, 0, 0 is 0, 1, 1 is 1, and the 1, 0 is 0. And what is A complement B? A complement means just we can multiply with this one and this one. So 1, 0 is 0, 1, 1 is 1, 0, 0 is 0, and 0, 1 is 0. And when we are adding this particular 2 term, okay, that time what happens? This particular outputs are coming. So when we are adding this 0, 0, it is 0. And when it is 0, 1, this one is 1. When it is 1, 0, this one is 1. And both are 0. That means obviously in OR gate, this one is 0. So we are getting 0, 1, 1, 0. Okay. And also the output of left hand side table, you see A XOR B, we are getting 0, 1, 1, 0. So both the outputs are equal. So we can say that A XOR B equal to A bar B plus A B bar. Okay. So this is the proof by the truth table. But sometimes what happens, generally some particular cases we are using, but what happens when your expression is very lengthy, that time what happens, this particular technique is not suitable, because your truth table is very large, and sometimes what happens, more confusion is created. Okay. So what happened? Now what happened? We are directly go to the Boolean algebra. So why Boolean algebra is required? See here, Boolean algebra is a system. Boolean algebra is a system of mathematical logic. Okay, because for when some particular logic is required, and that particular logic we can construct it with the help of Boolean algebra. And you know, in Boolean algebra, actually what is there? Some particular variables are there, operations symbols are there. Okay, variables also it is called literals, terms are there. Okay, so combination of this one, the Boolean algebra is constructed. And when we are talking about the mathematical logic, that particular mathematical logic is expressed by the Boolean algebra. Okay, just a minute. So next one is what? The Boolean algebra is governed by some contained well-defined rules and laws. So when we are constructing the Boolean algebra, or when we are deriving the Boolean algebras, that time what happen? Some particular we can follow, or we follow some particular well-developed rules and laws. That particular part we'll discuss later. So a complex logic statement can be expressed by a Boolean function. Okay, so what happen? Expression actually what happen? Some particular when we are deriving this particular Boolean function, that time what happen? Some particular expressions are created, which is constructed by the Boolean algebra. Okay, so what happens? Sometimes what happens that suppose we want to design some particular special type of circuit, and that particular behavior of that particular circuit defined by the Boolean function. And when we are deriving that particular Boolean function, that time what happens? We need some particular Boolean expression, and that particular Boolean expression is actually with the help of Boolean algebra. Okay, so always remember, when in Boolean variables, or you can consider as a literal, two valued variables that can take on two distinct values. When we are writing some particular variable, that time what happens? We are assigning either 0 or 1. Okay, only two particular logic values we can insert. One is called as 0 and another one is called as 1. Okay. A Boolean expression consisting of Boolean variables, constant, and operator, that particular part I have already discussed. Okay. But remember, when we are talking about the Boolean algebra, some particular rules we have to follow. Okay. And this particular one is sometimes called axioms and the laws of Boolean algebra. Some particular axioms, this one is called axioms. This one is called axioms. And some particular laws we are using. Okay, or laws, you can say rules. Okay, law. So axioms are nothing more than the definition of three basic logic operations. One, we are using AND gate, OR gate, or operation, or you can say AND operation, OR operation, and NOT operation. So this one is called a AND operation, this one is called a OR operation, or this one is called a NOT operation. Okay, so 0 into 0 actually 0. 0, don't use into. 0 and 0 equal to 0. 0 and 1 with 1. So this type of things are there. It is very simple. And when we are using 0 or 1, that time what happens? You can some particular book also it is writing like that. 0, 1 equal to also 1. Okay, that is this particular symbol is same. Okay, so these are the examples. The first law is complementation rule. If 0 complement, then you know the reverse, the output is the reverse from. So 0 complement equal to 1 and the 1 complement equal to 0. If a equal to 0, that time what happens? If when we are writing a means what? Here it is Boolean variable, or you can say switching variable, or you can say this one is the literal of that particular expression. When a equal to 0, then obviously what happens? A complement equal to 1. And when a equal to 1, that time what happens? A complement with 0. And when a double complement, that time what happens? It is equal a. Okay, this is called a complement law. Okay, what is the AND law? A and 0, that time what happens? Output is always 0. A with 1, that time what happens? Output is always a. A and a equal to always output is a into a means what? It is always a. And this particular rule we can directly write, suppose like that. We can extend with a term also. If I am writing AB here, A and B, suppose dot, okay, dot, and also I am writing here A and B. That time what happen? This one is also is called also it is AB.
Sir,
Yes.
sir, I have a doubt.
Please ask me.
Sir, in the second line you said 0 and 1 equals to 1, but actually it is 0, sir, I think.
Which one?
Sir, that after axiom, sir, 0 and 1 equals to 1.
This one. Second line. This one.
Yes,
This
sir.
line.
No, sir, I have that.
This one. This one.
Sir, the after axiom, sir, the line after the equation, yes, sir.
First line, sir.
Yes, sir, first line.
This one.
Yes, sir. So 0 dot
Oh,
1.
it is 0.
Yes, sir.
It is the type mistake. It is simple, na? 0.1, 0 into 1 is equal to 0. It is very simple. 1 into is 0. 1 into 1 it is 0. So it is printing typing mistake. Okay,
Yes, sir.
it is 0. So when we are considering when a dot a complement, it is also 0. Okay, this is called a AND law because here we are using AND operation. Every expression, every law, we are using the AND operation. So it is called a AND law. And OR law means what? A or 0, that means this one is A plus 1 is also we are considering as a 1. A plus A equal to A, and A plus A complement is also 1. Okay, this one is called a OR law. Now what happened? Another one is called a commutative law. Commutative law means what? A plus B we can write also B plus. Okay. And this law can be extended to any number of variables. Suppose if we are using, if we are using 3 variables, a plus b, we can write this way also, we can write this way also, we can write this way also. But remember one thing, in normal mathematics also we can write this a plus b plus c and b, but don't use the mathematic rules here, because this is the Boolean expression, and Boolean expression never follow the normal mathematics. Suppose this one, if you are writing suppose x, I'm writing here x. So x plus x plus, suppose I'm writing here y. Okay, and suppose you cannot say this one equal to this one. Suppose I'm writing here x, and also I'm writing here x, and I'm writing here z. So based on this particular expression, we cannot say in normal mathematics, you can say that y equal to z, because this one is cancelled. So you can say y equal to z. But in Boolean algebra, it is not like that, because in Boolean algebra, cancellation procedure is not possible, because there is no symbol in minus x. There is no variable we are denoting as a minus x. So though this particular rule, some particular rule are similar to the normal mathematics, okay, but don't think like that. You cannot use the mathematical concept in Boolean expression. Always remember. Okay. And you are getting or not?
Yes, sir.
Yes, sir.
Yes, sir.
So next one is the commutative law A dot B. A dot B we can write as a, we can equal to B dot A also. Okay. And if you are using some particular, if you are using more than 2 variables, that time whatever, this one is same. But difference is that here we are using the plus operation, and here we are using the and operation. Okay. So this type of law is called a commutative law. Okay. Next one is what? Associative law. So associative law means what? Allow grouping of variables. There are two associative law. One is this one. Okay, and it is extended to more than 3 variables or more than 2 variables. And this one also we are using the 3 variables when we can extend to the 4 variables. Here we are using the plus symbol. Here we are using the dot symbol. When we are writing in grouping form a plus b plus c, also we can write a plus within group b plus c. If we are grouping a dot b with c, that time also we can write a dot, meaning is same, a dot b dot c. Okay. So this particular law is called a associative law. So absorption loss law. So what happened? This one is a plus ab equal to a. And how we are getting? So you know 1 plus a. 1 plus a means what? When we are talking about the 1 plus a, see here 1 plus a equal to 1. Okay, so it is called a OR law. So if we are applying this one 1 plus b equal to 1 and 1 plus any variable add with 1, that time what happen, always it is produce 1. Okay, so what happen, how we can say that this one is called a absorption law, a plus a dot b equal to a, and we are getting this. And instead of what happen, if you are writing this way, a into a plus b, also we are getting a. So this is the derivation. Okay, so you know a dot a, this one, a dot a equal to what? A dot a equal to a. And this is coming from AND law. See here, a dot a, this one, a dot a equal to a dot a equal to a. So a dot a equal to a plus a dot b. So we are getting a. How we are getting a 1 plus, and this one is b. So you know 1 plus b equal to what? It is 1. So a into 1 with a. So here output is 10. So consistence theorem. This one is called a consistence theorem, and it says that ab plus a bar c plus bc equal to ab plus a bar c. Okay, and this theorem can be extended to any number of variables. If you are writing in this particular term, but remember this particular only we are using the two variable. This one is same. This one is also same. But here what happened? In this particular term, we are using some particular extra variable. Here it is d, but here it is only bc. Okay, that time what happened? What is the expression? Expression is also it is ab plus a bar c. Just a minute. Something I missed. This one. Okay. Okay. So this one is the theorem 1, and theorem B is something like that. If we are writing this one, a plus b a plus b into a complement with c and b plus c, that time what happened, we are getting a plus b with a complement plus. Okay, so this one is the consciousness theorem. Consciousness theorem. Okay, so this one is the first one, this one, and this one is the second one. But how we can prove this one? The first one proof is here. This is the proof. You can check yourself. If any doubt, then ask me. Okay. And second proof is what? We can consider at first left hand side. This one is the left hand side. Okay. And we are getting this one. When we are deriving this particular expression, we are getting this particular expression. Okay. And if we are considering only the right hand side, that time here we are considering only the right hand side, we are getting this particular expression. And this one and this one and this one are same. This one and this one are same. So we can say that this particular expression equal to this particular expression. So here I am using equal. Now we are using equal. Okay, this is the proof. So you can see this particular two, how we can prove this one. If any doubt, then please ask me. I am waiting for your response. Okay, you carefully check. You can write down this particular expression on your copy and try to understand. If you are getting any problem, then you can ask. Any doubt?
No, sir.
So why actually these particular rules and exams are required? Because remember one thing, suppose when you are going to design one particular circuit. Okay, so what happened in that particular expression, Boolean expression? Suppose one particular student considering only three particular terms in that particular expression. Okay, and one particular student only using the two terms in the same expression. That time what happened when you are converting that particular expression to the logic circuit? If your expression is minimized from or minimum from, that time what happened? When you are constructing your circuit, you have less, that means less number of gates are required. Okay, suppose other students are using only three terms instead of two terms. That means what? When he constructing the circuit, that time what happened? Number of gates are more because their expression is, it is not a minimized form. Okay, so always remember this particular Boolean expression is very essential in digital logic circuit. For the when you are going to design the circuit, that time what happened? This particular expression is very important. So if you don't know the exact rules or exams, that time what happened? You cannot minimize the Boolean expression. Okay, and when you are minimizing the Boolean expression, that time what happened? If you are capable to minimize the Boolean expression, that time what happened? Your circuit also very in the reduced form. Your circuit also in the reduced form. Okay, and you know what is the benefit of the reduced circuit? That means whatever you can, when you are designing, when you are converting in the into the IC, that time whatever less number of gates are required. When less number of gates are required, that means fabrication process is minimum, and also your power dissipation is also minimum. Your complexity of the circuit also minimum. So there are a lot of advantages are there. So whatever all the concept is coming from the Boolean algebra. Okay, so always remember, so this particular all the rules are very important. Okay, so if you are know this particular how we can prove, then it is okay. Then we are going to the next slide. Okay, another particular laws are there, that is called a distributive law. Okay, what is the distributive law? A plus A into B plus C. That means B plus C, remember, B plus C within the group. So if you are using the first bracket, it is not a curly bracket, first bracket, B plus C, that time what happened? We are derived this way, AB plus AC. AB plus AC equal to A into with the B plus C. This particular one is called a distributive law. Second of the distributive law is A plus BC. We can write A plus B with the group and A plus C also with the group. And in between A plus B and A plus C, there are n operations are there. This one is the n operation. Okay, this one is the plus operation. Okay, so how we are using it? Suppose it is very simple. Suppose here, if you are multiplying AB plus C, that time what happen? We are getting AB plus AC. And if you are getting A plus BC, that means what? A plus B is equal to, you can consider here AA, after it AC, after it AB, that time what happen? Obviously you are getting A plus B. You can try yourself how we are getting A plus BC. It is very simple. Okay. And these particular rules generally we are not using, but sometimes it is, sometimes no, many cases it is required. So it is called a useful law. Okay, but you are not identifying from the book, actually it is useful law. So what is this? A plus B, A plus A bar B, we can write A plus B. And when A into A bar plus B, that time when we can write A into B. Okay, so how we can get this one? Suppose here, suppose here I am writing A. Here I am writing suppose A. You can try yourself. This one is very easy. How we are getting A plus B? So A plus B, A dot A, suppose whatever here you can insert B plus B bar, because here B is missing, so B plus B bar, and we can derive this one. You can get this one A plus B. Okay. So this one is called a useful law. And what is called a De Morgan's theorem? So A plus B whole complement, we can write A complement into B complement. Okay, and another De Morgan's theorem is that just opposite A dot B complement, that means A into B complement, whole complement, then we can write A complement plus B complement. And this particular two laws, two expression, we can extend it any number of variables. We can, if we are writing here A plus B plus C whole complement, then we can write A complement dot B complement dot C complement. And if you are writing here A dot B dot C complement, whole complement, that means we are writing A bar B, A complement plus B complement plus C complement. and this particular, so this particular two expression is included in the De Morgan's theorem. Okay, so any doubt this one, up to this one, any doubt?
No, sir.
Okay, so next class on Tuesday na? According to our timetable, the next class in which date particular? Tuesday, on Tuesday na?
Yes, sir.
So Tuesday I will take the class. Okay, Wednesday, according to the timetable, class will be started from 10 to 11. Okay, that particular date I am not taking the class. Okay, I am just taking, I will conduct the exam. So 10 to 11, it is your first internal exam on Wednesday. But on Tuesday, I will continue my class from 9 to 11. Okay, but remember one thing, up to this, this is the lecture 11 up to lecture 1 for introductory class to the introductory lecture to lecture 11. This is your syllabus for first internal exam. And also you can check from the instruction manual, whichever I have already provided to you. So there, unit 1 is covered. All the topics of unit 1 is already covered. And unit 2, only you can check this today's class. Okay. But remember one thing, some particular how you can clear all the laws and exams. Okay. So I'm already covered this one, but how to minimize the Boolean expression, what type of techniques I'm using, and how Boolean expression convert to the logic gates. Okay, and how we can convert to the logic circuit. That particular parts are not included in first internal exam. Are you getting my point?
Yes, sir.
Yes, sir. Yes, sir. Class করতেছে না। Maths. দেখো না, আমি ক্লাস করলাম তো।
Okay, so I am stopping here. That means today class is already completed. Okay, so next class I will start on Tuesday. Okay, so and always one thing is remember, I am sending the test link, not a WhatsApp group. I am sending the email to your class representative. And the class representative, within the 2 minutes, you just forward that particular link all the WhatsApp group. On the link to the WhatsApp group. Are you getting my point?
Yes, sir. At what time you will send it?
So why you are not reading the instruction? You can read the instruction.
Yes, sir. It is written before 3 minutes. Right?
Before 3 minutes means what? Class in my that is the one particular problem. My time is 11:01. Just you can synchronize the time with me now with my system. My time is 11:01 now. Okay. So whatever according my system time, actually I am synchronized. Okay, you can maintain, but it is no problem. It is okay. Before 3 minutes, I will provide the link, and after that, whatever, just within that particular 3 minutes, you can send you can send that particular link to the WhatsApp group so that all the students get that particular link. But remember one thing: if you don't submit before on time, be on time or before time, that time or after time, that time whatever, I cannot do anything. And there is no excuse. And generally, I'm giving the excuse. Okay, and it is your duty which particular device you are using. You are using laptop, mobile. It is your choice. But remember one thing: don't use like that. कल से सर electricity नहीं है मेरा घर में, वो नहीं है, वो नहीं है, वो नहीं है. उसके पहले आपको preparation कर लेना पड़ेगा. ठीक है? So जब तक एक मेजर कुछ प्रॉब्लम ना हो और वो भी इवैल्यूएट होगा एसओडी से और मेरे से. ठीक है, आप लोग बोलेंगे सर ये हुआ मेरा घर में, ये आ गया, तूफान आ गया, मेरा घर चला गया, वो हो गया. सो जेन्युइन रीजन होने से मैं कंसीडर करूंगा, तो उसका चांस बिल्कुल जीरो है, ठीक है। सो जस्ट मेंटेन योर प्रॉपर टाइम। आप लोग को 10 बजे के पहले ही बैठना है, ऐसा नहीं है मैं घर में हूँ कोई नहीं देखेगा मैं आराम से बैठूंगा, इट इज नॉट लाइक दैट। जैसे आप लोग का नॉर्मल क्लास होता है, जैसे आप लोग का जब यूनिवर्सिटी को डिपार्टमेंट खुला रहता है, डिपार्टमेंट के पहले क्लास होने के पहले जैसे आप लोग आते हैं उस हिसाब से भी आप लोग प्रिपेयर करेंगे, ठीक है। और एक बात याद रखिएगा कि आप जब एग्जाम देंगे तब आप मोबाइल दूसरे को पूछ सकते हैं, आपका फ्रेंड को फोन करके, वो करके कोई फायदा नहीं, क्योंकि जो क्वेश्चन आएगा वो सफलिंग ऑर्डर में आएगा, आपको पता भी नहीं चलेगा कौन सा क्वेश्चन। ऐसा भी हो सकता है जो क्वेश्चन आपका आ रहा है आप बोलेंगे कि नंबर 2 क्या है, दूसरे को अगर पूछेंगे जब तक उसको क्वेश्चन को रीड करने के लिए आपके पास टाइम नहीं रहेगा, सिर्फ 1 आवर का टाइम दिया जाएगा। ऐसा भी हो सकता है क्वेश्चन नंबर 1 जो आपके पास है वो दूसरे के पास नहीं, वो दूसरा भी हो सकता है, ठीक है। So it is for just notification to you, just warning to you. So don't consult with your student. जो आपको आता है वही कीजिए आप। Okay. So I am requesting all of you just maintain the time and timely you can submit your response. Suppose 11 is the closing time, 11 a.m. Why you are not submitting 10:58 or 10:59? Okay. And 20 minutes I am giving more according to the question. I am giving 20 minutes more. This is only 10 question and it is multiple choice question. Generally it is not required 1 hours. Okay, ये 40 minutes पर 30 minutes में ही complete हो जाएगा। तो आप लोगों को ऑन टाइम में लास्ट डेट में, क्योंकि आपका घड़ी अगर 10:59 दिखा रहा है लेकिन मेरा सिस्टम ऑलरेडी 11 हो गया तो प्रॉब्लम हो जाएगा। सो जनरली क्या कीजिए आप लोग 2 मिनट के पहले ट्राई कीजिए। ओके, जस्ट लीव one by one.
Thank you, sir.
Thank you.
Thank you, sir.